We've seen before that we could graph a single inequality by drawing a line, graphing a line, and then shading on one side of the line. Well, now we're going to graph a system of inequalities. Two, we could have more, but we're going to only work with two today. Two inequalities. And when we do that, we're going to find that these two lines, many times, in this example for instance, they're going to intersect, and we're going to break our grid, our plane, into different regions. So I've written two inequalities. We're going to graph two lines. We'll call one of them, the first one, the red line, and the second one is the blue. But let's pay close attention to our inequality symbols. This red inequality has a strict inequality. In other words, there's no line under it. So when we graph this red one will be a dotted line, or a broken or a dashed line. We'll do that one first. But later we're going to do the blue inequality. That's not a strict inequality. It's got the little line under it. So this will be a solid line. Let's start with this red one, though. The intercept is positive 3. It'll be here, the y-intercept. And our slope is negative 1/3. So our line is going to go downward like this. Specifically, it's going to go down 1 and over 3. Down 1 and over 3. And we'll make several points until we kind of run out of room. The more points we have, the more accurate our graph will be. I'm just continuing to go down 1 and over 3. As I do that, you can see that these red points line up. They fall in a straight line. Okay. So remember that since this is a strict inequality, there's no line under here, this will have to be a dotted line or a dashed line. So do your best to make sure that you show that. That's good enough. A dotted or a broken or a dashed line is what we need. Now, I'm not going to shade this yet, but I'm going to write a word on here. This says that y is less than this line. So when we do shade it, we're going to shade below this red line. I'm going to write the word below here in red. Now let's work on the blue inequality. Our intercept here is negative 2. Here's negative 2, the y-intercept. And our slope this time is positive. To be specific, it's positive 4/3. So it's going to be going upward. It's going to go up 4 and over 3. 3, 4 and over 3. We already have a point there. Up 4 and over 3. We're going to keep doing that till we run out of room. Up 4 and over 3. And we can also plot points down in this direction too. Down 4 and 3 in this direction so that they continue to lie in a straight line. Okay, it's a good idea to plot as many points as you have room for. The more you have, the more accurate your line will be. Again, the difference between this red and this blue is that we don't have a strict inequality here. We have this line under here, so this line is going to be solid. Okay. And let's now pay close attention to the inequality symbol. This says less than. So we're also going to shade below this blue line. I'm going to write the word below here. So when we only had one of these inequalities, we would shade either on this side of the blue line or on this side, or on this side of the red line or on this side. But now we've broken up our plane into 4 regions. I'm going to label them. You could use any letters, but I'm going to use the letter A and B and C and D. This region is region A, all of this in here. This is B. Everything in here will be C and D. Now, you don't have to use these letters. You could use anything you want. But we want to take a minute to think about which region is below the red line and below the blue line. There's only one of those 4 that will satisfy both conditions, being below the red line and below the blue line. And that's going to be this region, region C right here. So we'll want to shade everything here, and only here. Sometimes the way some people do it is they'll shade one half of the plane and then the other half, and they kind of, darken in the part that's on both. But I don't want you to do that. I want you to only shade the region that we're interested in. Of course, we can always test our solution. We can choose any point that's in this region and make sure that we can substitute it back into both inequalities. So I'm going to go ahead and do that. I'm going to pick a point that's relatively easy to substitute in. Let's say, how about this point right here? It's going to be a small number, I think. Isn't this, I'm going to make it darker, but isn't this here point going to be 4, -1? So I'm going to test 4, -1. Let's see if I have room on the bottom here. So for the red inequality, I could substitute those numbers in. I think I'm going to choose another point here. I'm going to choose 3, -1 instead. 3, -1, not 4, -1. 3, -1. That'll be easier to work with. So I'm going to use 3 and -1. I'm going to make that a darker. Darker print here. 3, -1. I want to test to make sure that when I substitute that into both of these, that I get true statements. And by the way, I chose 3 because our denominator here is 3. I could have chosen any number, but I don't want to work with fractions. So if I put a 3 here, I won't have to deal with fractions, or any multiple of 3. I could have chose 6 or something like that. 3, 6, 9, 12, and so forth. All right, so I want to substitute 3, -1 into this inequality. Let me write it down below here, into the red, and also into the, if that's going to show up, -1/3 times x plus 3. So for y, I'm going to put a -1, and for x, I'm going to put a 3. And we'll see if that makes a true statement. I think I have just enough room. I think I'll write it over here. Won't this give us -1? That'll be less than, if we multiply -1/3 times 3, these will cancel. We'll get -1 plus 3. And this will give us positive 2. So isn't it true that -1 is less than positive 2? Of course that's true. And just so that I don't run out of room, I'm going to do the blue. I'm going to test the blue one over here to the side. Blue inequality. So I'm going to write, instead of y is less than or equal to 4/3 times x minus 2, I'm going to replace my my y value with -1. Let me just write it in here. And my x value with 3. So this will leave me with -1, less than or equal to. These 3's will cancel. And that's why I chose the 3, so that it would cancel. We'll have 4 minus 2. Of course, 4 minus 2 is 2. So isn't it also true that 1 is less than, -1 is less than 2, just like before? Of course it is. So this point, when we substituted its coordinates into both equations, or either equation, we got a true statement. So we can be confident that this point lies in our solution, and every other point that's in this shaded region. So this shaded region is the set of solutions. Any point in this region would satisfy both of these inequalities. That's our solution.